You know that moment in table tennis, watching an elite player seemingly teleport across the table, paddle a blur, ball just zipping back and forth. It feels like pure instinct, maybe incredible reflexes, but what if the true secret, the magic behind those lightning-fast returns, and surprisingly, even preventing career-ending injuries, isn't just about their hands, but actually hidden in their feet? Today, we're taking a deep dive into exactly that.
That's right. We're peeling back the layers on the intricate biomechanics of how elite table tennis athletes actually move their feet. Our exploration today is built on some really fascinating new science. It's an article titled Chasse-Step and One-Step Footwork reported different biomechanical profiles in elite table tennis athletes.
Okay, that sounds specific. Who's behind this research?
Yeah, it's groundbreaking work by Xiaoyi, Wang, Qichang, Shirui, Shao, Yaodong, and Justin Fernandez. And it was just recently published in the Journal of Sports Science and Medicine, Volume 24, actually.
Great. So our mission today is to truly understand the distinct biomechanical profiles of two absolutely fundamental footwork techniques, the Chasse-Step and the One-Step. We'll try to uncover what these differences mean, not just for, peak athletic performance, but also for potential injury risk down the line. And for those of you who love to know how science gets done, we'll also shine a light on the cutting-edge methods these researchers use to get these insights. Let's break this down. So to start, why is footwork so crucial in table tennis? From the stance, it really seems like it's all about the paddle, the spin, the power of the arm. But this study really emphasizes the importance of what's happening beneath the table with the feet. Did this study reveal anything that genuinely surprised you about the underestimated role of the feet in what often looks like an upper body sport?
Absolutely. It's fascinating because while we focus on the shot itself, the feet are constantly working, constantly adjusting to put the athlete in the optimal position. Table tennis is such an explosive sport. It demands this masterful blend of lightning fast movement coordination, efficient power transfer from the ground up, and really precise balance control.
Right. If you can't get to the ball quickly and stably.
Exactly. Even the best paddle technique is useless then. The study highlights several basic types of footwork. You've got the one-step, the Chasse-Step we're focusing on, but also slide step, cross step, pivot step.
Lots of ways to move.
Definitely. And we even know from previous research that, for example, certain groups, like Asian athletes, have historically shown quicker footwork performance compared to Europeans. And male athletes often prefer the one-step and pivot step more than female athletes do.
Huh. That's interesting. Suggests different training or maybe even physical factors.
It really underlines how diverse approaches and, well, physiological factors are at play. Could be training methodologies, could be physical predispositions, something that probably warrants more study, actually.
That's a great point about getting to the ball. I remember trying to mimic a pro player's footwork once, just messing around. And after maybe 5 minutes, my feet felt like they were on fire. It makes you really appreciate what these elite athletes do and why understanding the how is so important. So, given how complex these movements are, how did these researchers actually capture such precise data? They couldn't have just used a stopwatch or something, right?
Not at all. No. What's truly groundbreaking here is the advanced approach they took. They didn't just observe, they used incredibly sophisticated techniques to capture every subtle movement, every force. First, they carefully selected their participants, 18 elite Chinese male table tennis athletes, all national level I, all right-handed, and crucially, none with any history of lower limb pain or injuries in the last 2 years.
Okay, so really focusing on healthy peak performers.
Exactly. That's vital for ensuring the data truly reflects, optimal biomechanics, not compensations for injury. Then the experimental setup. Well, it was a biomechanist dream, really. They used an incredibly precise 8-camera motion capture system, think Vicon, to record the exact trajectories of 52 reflective markers placed strategically on the athletes' bodies.
Wow, 52 markers, like little constellations moving around.
Pretty much. It gives you a full 3D map of the body's movement. Simultaneously, they had an in-ground force plate AMTI brand recording the ground reaction forces. That tells you exactly how hard and in what direction the athletes were pushing off the ground with each step.
Okay, motion and force. What else?
And to top it off, they use surface electromyography, or EMG. They put sensors on the skin over specific muscles. This measures the electrical activity of those muscles, giving them a direct look at how hard those muscles were actually working during the footwork.
It's an amazing level of detail. But then they took all that raw data, the marker positions, the forces, the muscle activity, and did something even more complex with it, right?
Precisely. This is where it gets really sophisticated. They fed all this data into something called OpenSim Musculoskeletal Modeling Software, version 4.2. Think of it like this. They took all the data from the cameras, the force plates, the EMG, and fed it into this incredibly smart software.
Okay.
It builds a perfect digital twin of the athlete's lower body. And then using the laws of physics and biomechanics, it calculates all the invisible stuff. Things like how much rotational strain or moment was on each joint, hip, knee, ankle, how much force was going through the joint surfaces themselves. And it could even predict the muscle activation patterns needed to create those movements.
So it calculates forces inside the body.
Exactly. Joint angles, joint moments, joint contact forces, muscle forces, things you just can't see from the outside. And importantly, the EMG signals they collected directly from the muscles were then used to validate the model's predictions.
Ah, so they checked if the computer model matched the real muscle activity.
Correct. It ensures that their virtual athlete was behaving just like the real one. This approach gives you a level of insight that, just watching even slow motion video could never achieve.
That's quite profound when you think about it. We're moving beyond just watching a sport to truly understanding the intricate physics and biology of human movement in real time. So with all that incredible data from their digital twins, what were the main findings? This is where it gets really interesting, right? The specific, quantifiable differences in how these two common footwork techniques, the Chasse-Step and the one-step, impact the body, right down to the joints and muscles. It's like they've given us an X-ray into the athlete's movement.
That's a great way to put it. And if we start our X-ray at the hip joint, what we see is quite distinct between the two steps. For the one step, the model showed an increased hip flexion angle, basically. The hip bent more forward, and also an increased hip flexion moment, or rotational force, during the leg's backward swing phase as the athlete prepared to step forward.
Okay, more bending and force at the hip going into the one-step.
Right. And you also saw increased hip contact force, specifically in the anterior-posterior direction, that's front-to-back force through the joint. Now, in contrast, the Chasse-Step specifically showed increased hip contact force in the medial-lateral direction.
So side-to-side force for the chase.
Exactly. So right away, we're seeing completely different stress patterns being placed on the hip joint depending on the footwork used.
Okay, that makes sense. And moving down to the knee joint, did the differences continue there?
They did, and quite clearly. For the knee, the Chasse-Step demonstrated increased knee extension, meaning the legs straightened out more during the leg's forward movement phase. Conversely, the one-step showed increased knee flexion, the knee bent more, or stayed more bent during that same forward swing phase.
So it's like the Chasse-Step involves more pushing off, extending to propel sideways maybe, while the one-step keeps the knee more bent, perhaps for a quicker, more compact movement.
That's a really good interpretation. It certainly looks that way from the data. The Chasse-Step seems geared towards covering ground laterally, while the one-step might be more about that rapid forward adjustment and stability for the stroke.
And what about the ankle? Did the study touch on that too?
Yes, briefly. The data indicated that the one-step involved more dorsiflexion. That's when your foot flexes upwards towards your shin. And it also showed a greater plantar flexion moment, which is the rotational force involved in pointing your toes downwards, like when you push off. Both footwork types also displayed distinct contact force patterns at the ankle, again highlighting that different demands are being placed pretty much on every major joint in the lower body.
Okay, hip, knee, ankle. Distinct patterns for each step. Now, what about the muscles driving these movements? You mentioned EMG was used.
Right. The muscle activation data, gathered through those EMG sensors and then cross-validated with the OpenSim model's predictions, provides crucial insights. It tells us which muscle groups are doing the heavy lifting, so to speak. They found pretty distinct patterns. Essentially, it showed that the one-step relies more heavily on certain muscles for that explosive forward movement and then stopping quickly. Think quadriceps and shin muscles.
Like which ones specifically?
For instance, the rectus femoris, which is one of your main quad muscles at the front of the thigh, showed moderate to strong activation during the stance phase of the one-step. Also, the tibialis anterior, a key muscle in your shin responsible for pulling the foot up, measured a greater amplitude, more activity in the one-step.
Okay, quads and shins firing up for the one-step. What about the chest step?
Well, conversely, the Chasse-Step seemed to heavily engage the calf muscles, likely for those powerful side-to-side pushes and for stabilization during lateral movement. Specifically, the gastrocnemius medial, which is one of your main calf muscles, exhibited a greater level of activity during the Chasse-Step.
Calves working hard for the side-to-side chase. Any other muscles?
Interestingly, yes. Two other quad muscles, the vastus lateralis and vastus medialis, sort of on the outside and inside of the thigh, showed smaller overall activity levels, but the difference in their activity between the two steps was statistically significant. So even within the quads, there are nuances in how they contribute differently to each step.
That's a lot of incredible detail about which specific muscles are working harder. But for our listener who isn't necessarily a biomechanics expert, can we distill this a bit? What's the practical, everyday takeaway for an athlete or coach from knowing, say, the rectus femoris is more active in the one step versus the gastrocnemius in the Chasse-Step?
That's a fantastic point and really the key question. So what does this all mean for athletes and coaches on the ground? If we connect all this granular data, the joint angles, the forces, the muscle activity to the bigger picture, these distinct biomechanical profiles aren't just fascinating numbers. They tell us a profound story about performance potential and, critically, about hidden injury risks.
Okay, let's get into that. Performance and risk. What did this study suggest for the one step?
Right. For the one step, this research suggests it's strongly associated with faster performance for scoring for directly winning points. Aggressive play. This makes intuitive sense when you consider the biomechanics they found. The increased hip flexion and knee flexion. These likely help stabilize the body for those quick, powerful strokes. They allow the dominant hand to really move forward effectively, generating that impact-hitting force.
So the go-to for a quick attack. But what's the downside?
Well, here's the important question it raises. While it's fast and effective for scoring, the study clearly suggests a potentially higher injury risk, specifically in the hip joint. This seems linked to the high involvement and significant forces placed on both the hip and knee joints needed for stability during this explosive, often repetitive movement.
Right. A high reward, but potentially high-risk maneuver for the hip then.
Yeah.
And what about the Chasse-Step? What's the story there?
Exactly. Now, looking at the Chasse-Step, the findings indicate it's more associated with performing high-quality strokes and, importantly, efficient preparation for the next phase of play. It's more about consistency and setting up.
So less about the immediate kill shot, more about covering the court and staying in the rally.
Precisely. This footwork emphasizes that side direction movement, which is perfect for allowing athletes to cover those medium distances across the table, maybe retrieving a wide ball and then strategically preparing for the subsequent stroke. The increased knee extension they observed during the forward swing phase points towards improved movement quality and efficiency in covering that lateral distance.
Okay, sounds good for court coverage. But is there a risk factor here too?
Yes, there is. And this is a significant finding from the study. It notes a higher potential injury risk, specifically in the knee joints with the Chasse-Step. This seems to be due to the high loading profiles, the forces and stresses placed specifically on the knee during this type of side-to-side shuffling and pushing movement.
So one step might stress the hip more, Chasse-Step might stress the knee more. That's incredibly specific.
It is, and this information is incredibly valuable. Knowing these specific demands on different joints and muscles for each type of footwork can really inform how athletes train and how coaches design their programs. It lets you move beyond just generic get stronger conditioning to truly targeted preparation and hopefully injury prevention strategies.
Yeah, you could potentially tailor exercises to strengthen the specific muscles and stabilizers needed for an athlete's preferred or most used footwork style. And it's also worth reiterating that the OpenSim modeling proved reliable here in predicting the muscle activities, matching the EMG. That adds a huge amount of confidence, right?
Absolutely. It validates the approach and means these kinds of detailed biomechanical models can be trusted more and more for future research. It shows the virtual models are truly capturing what's happening in the real world, which is fantastic for sports science.
Okay, so a really insightful study. But, every groundbreaking study has its boundaries. What do you think might be some of the inherent challenges or limitations they faced in trying to capture real-world performance in a lab setting? What would you want to see next?
That's a great question. You always have to consider the lab environment versus the real chaos of a match, right? I imagine that the experimental environment being strictly lab-based is one limitation. Maybe the movements, while precise, were slightly more controlled or predictable than the rapid, sometimes desperate reactions needed in a real match.
Yeah, the pressure and sheer variability of actual competition is just hard to replicate perfectly. Maybe the lack of a robot serving balls adds to that.
That could be a factor too, yes. The predictability of serves or ball placement might differ. So future studies could definitely try to incorporate robotic ball machines for more consistent, yet still challenging match-like conditions. Or perhaps even look into using mobile motion capture systems, those are getting better, to analyze players during actual training games or even competitions. That would really bridge the gap between the lab and the court.
Taking the lab onto the court, essentially.
Kinda, yeah. And another key point is that this study focused exclusively on the lower limbs. As we know, table tennis is a whole body sport. Power comes from the ground up, so future research really should consider a combined upper and lower extremity analysis. We need to see the whole kinetic chain.
Understanding how the leg drive connects through the core to the arm for the actual strike.
Exactly. Understanding how these systems integrate footwork, core stability, arm mechanics, that will be the next frontier in truly optimizing total body performance and hopefully preventing injuries throughout the chain, not just in the legs.
And there you have it. We've explored how the Chasse-Step and the one-step footwork, while both absolutely essential tools in the elite table tennis player's kit, demand quite different things from an athlete's body. This impacts not only their strategic performance choices when to use which step, but also, as we've heard, their susceptibility to very specific potential injuries, maybe in the hip with one, maybe in the knee with the other. So for you listening, whether you're a player striving for that extra edge, maybe a coach looking to refine your training methods, or perhaps just someone like me who loves understanding the incredible science behind elite sports, this deep dive provides some solid, evidence-based insights into optimizing movement and, crucially, thinking about how to prevent injury in a more targeted way. So here's a thought for you to mull over as we wrap up. What if tailoring an athlete's training wasn't just about making them stronger or faster in general? What if it was about truly understanding their unique biomechanical profile, maybe their tendencies towards one step or the other, and then using that knowledge to mitigate the specific injury risks associated with their preferred footwork? Imagine the potential impact on career, longevity, and health. If you found this as fascinating as we did, we definitely recommend reading the full article for all the details. You can easily find it by searching its title again. Chasse-Step and one-step footwork reported different biomechanical profiles in elite table tennis athletes, published in the Journal of Sports Science and Medicine. And of course, be sure to follow our channel and turn on those notifications so you don't miss our next deep dives to the science behind what makes us